Hi everybody, good evening. Hope you be great. Welcome back to again today's session of learning physics with me. Again it is based on Newtonian second law of motion. I am taking impulse. Before starting, I would like to draw your kind attention about some important facts about the impulse. The measure of total effect of force is called impulse. You must have clear of a force is the total effect of force. Impulse is the total effect of force. Impulse force doesn't remain constant but changes from 0 to maximum and maximum to 0. Third one point is impulsive force is the product of force and the time for which the force acts on the body. It is the measure of impulsive force. Impulsive force is the product of force. Let us write. Impulsive force is the measure of product of force and time. You should be very clear that impulse is the effect of force. So, impulse can be defined as impulse is equal to force into time. Force into time which will give you effect of the force. Which will give you effect of the force. We have from Newtonian second law. Now let us derive it. We have from Newtonian second law of motion. Force is defined as rate of change of momentum. As I have discussed earlier classes, force is defined as rate of change of momentum. Therefore, F dt is equal to dp. Now we will integrate both sides under the limit for time as t is equal to t is equal to 0, and for the momentum, the limits will be, upper limit will be p2 and lower limit will be p1. Let us suppose. So F dt is equal to dp. The limit for time will be upper limit t, lower limit 0, because the body is starting from 0. So lower limit will be 0. Let us consider that it reaches at some point after at time t. Let the initial final momentum is p2 and initial momentum is p1. Then we treat final momentum as its upper limit and initial momentum as its lower limit. So after integration we get ft under the limit t to 0 and p means momentum. The integral of dp is p. The integral of dt is t. So limits are p2 and p1. This will give you ft minus 0 by putting the limits, and on the RHS it will give you p2 minus p1. It will give you p2 minus p1. So we can see here f into time, force into time. Force into time is equal to p2 minus p1 is equal to p2 minus p1, and as I have discussed earlier classes, p2 minus p1 is change in momentum. P2 minus p1 is change in momentum. And here we have defined impulse is force into time. So force into time is impulse. So in brief we can say that impulse is nothing but change in momentum. Impulse is nothing but change in momentum. Again, from this equation we can get force is equal to p2 minus p1, that is change in momentum divided by time. Force is equal to change in momentum divided by time. This is rate of change of momentum because we have divided it by time. This will be called rate of change of momentum. Rate of change of momentum. This will be give you rate of change of momentum. Now I will draw your attention to get understand this thing by a graph. On the y-axis, let us taken the force of the body, and this axis, that is x-axis, is about time. This is origin. Let us F1 force is applied at time t1. Then the impulse will be force into time. F1 force is applied. This is situation 1, F1 force for time t1, and this is situation 2, F2 force, situation 2 for time t2. Then clearly we can see from the graph that change in time is t2 minus t1, which is equivalent to t, and we can see from the graph F1 is greater than F2. F1 is greater than F2. When F1 is greater than F2, then clearly T2 is greater than T1. You can see from the graph T2 is greater than T1, but F1 is greater than F2. This implies force is inversely proportional to time. This implies force is inversely proportional to time, implies Ft is equal to constant. That is impulse. Force into time is constant. implies F1 T1 is equal to F2 T2. F2 T2, which is constant, because constant in each moment, momentum is constant. We can see here, if we increases the time, the larger the time, the effect of the force will be smaller. The smaller the time, the effect of the force will be larger. Given for a given change in linear momentum can produce a smaller force for a longer time. This is why a cricket player pull back his hands so that increases his hands doesn't get injured. Again listen, a given change in linear momentum can produced by applying larger force for a smaller time or a smaller force for a longer time. This is why a cricket player pull back his hands so that time increases and his hands doesn't get injured. Thank you for watching. I hope that this video will be helpful for you. Like it, share it. I will meet you with a new video next day. Till then, take care and bye.